So guys, here we are back again in line. My name is Fimo Beitler. I'm moderator of today's meetup. Is the Introduct Flutter meetup day. So uh, before me here was Vasil Ditsak, and now we are up to a next speaker, Darel Bitsy from Dnipro. He's senior Flutter developer and team lead. And I will. Oh, here we are. Darel, do you hear me? Do you hear us? Say
Yes, I
something.
can hear you. Hi.
Oh, nice, and I can hear you. How are you, Darel? How it's in Dnipro?
Everything's fine. Just a little bit rainy, but everything's all right.
Oh, wait a second. I can hear you. What did you say?
I said everything is fine. It's a little bit rainy, but
Uh huh.
everything is all right.
Okay, yeah, nice. I hear you. So it's kind of a little bit snowy here in Kiev, but it's all right and it's good. And we're here live streaming with you. So Daryl will tell you about things like trunk-based development on Flutter, architecture guideline, tests and testing rules, and more. So we are ready to hear you, Daryl. And guys, if you have some questions, just write them to the chat while Daryl is online, and I'll ask them after his speech. So, Daryl, they are all yours. Here we go. Next, Daryl.
Okay. So, hi everyone. Can you guys see my screen? Can you see the presentation? Hello.
Daryl, we
Can
can
you hear
hear
me?
you and we can see you, and the guys too. We can see the
Yes.
chat.
And can you see my screen?
Yes, we can see your screen
Okay.
just right now.
Good. Okay, good. So basically, today I will be talking about development process for effective Flutter team. So, this talk is quite different from the all of the previous talk that I have done because it's more about how to build a effective team for a Flutter application, and it's not all about like C++ or like any other talk that I've been doing so far. So who am I? So my name is Darel Bitsy. I am a team lead and tech lead for both native Android, native iOS, and Flutter. I have been doing Flutter since 2018, 19, I think, yeah, until now. So I have been also working on other technology as WPF, Spring, React Native sometimes, and more. So on the left down side, you have all of my socials: LinkedIn, GitHub, Twitter, and email. Feel free to contact me if you have any questions at some point or later. And a fun fact about me is that uh, I like to automate everything that I can find. Like if I see myself doing something more than 2 3 times, I'm I quickly start to look how I can automate this thing because I don't like repeating stuff more than 3 times actually. Yeah. So one thing I want to make clear is the difference between effective and product. So productive teams are teams that have the ability to make a lot of things, basically to generate many things. And effective teams are teams that have the ability to solve problems the right way. And in our industry of software engineer, what we want is to basically to impact business in a positive way, to basically solve business problem the right way. So in our field, the IT field, we don't. The goal is to basically not is to not generate more software. Like it's not to generate like many things. Is to generate the right software to solve the right problem. So that's why it's really important to have first an effective team, a team that can solve problems, business problems, the right way and effectively. So today we will see some of the patterns, some of the things that you can apply to your teams or applying to your project to make well to make your development process more effective and also your team in general more effective. So the agenda of this talk is to basically first see how you can effectively define requirement, because basically before starting development you have to first have requirement on what you want to develop. So we will see how to make that process of from the moment when the idea is on the business analyst or the product owner to the developer which have to write the code. And after that, we will see how to effectively basically create a implementation design of that requirement for the development team to implement that. And last, we will see how to effectively develop software. And also, of course, we will see how to effectively have a team collaboration, because collaboration is really important if you want to have an effective team. So you need to be able to collaborate, to share, to talk, and to discuss various topics and various issues. And last, I will send you the link to a example project that you can see basically from the requirement definition to the software development, and of course some of the bit on how you should do collaboration. So let's start. So effective requirement definition. So to effectively define requirement, you first need to define some standards. So you need to define, for example, as a team, how should user stories or epic, whatever you use or task, need to be defined. You need to decide the template. If you're going to go with a as as a persona, I want to so that I can this, or like if you will go with some, or if you will go with some other type of standards. So you need to also define the information that are necessary in a ticket. For example, you can say, okay, I need a ticket to be properly written in English. I need the ticket to have at least wireframe. If there are ticket that, if there are user story or ticket that need to work on the UI, I need them to have wireframe design no matter what. The story, user story or ticket has to have acceptance criteria or fit criteria. Also, you can also define, for example, that a user story need to have for example some information on the API that need to be used or something else. Then after the business have after you have defined those rules, those templates, those standards, you have to document them, because what happens is that you can define some standard today and tomorrow everybody will forget about them, or like everybody will like to understand, okay, right now I'm trying to create this user story. How with the team did we agree on creating that? So if you have those standards and template documented, everyone coming to the team, like the tech lead, team lead, the PO or the business analyst can just go through that documentation and start writing the user story that follow the standards and the template that you have agreed as a team. Next, after you have defined those standards template for your user story, every user story before they go to the development team need to be reviewed by a TA. What is a TA? So a TA is a technical authority. So, for example, let's say, for example, the business have decided, okay, we want to be able to implement Apple payment, like Apple Google payment on our application. So this requirement is right-hand. So we need the user, as a user, I want to be buying, for example, some goods. And then the TA need to review that requirement to make sure that, first of all, it has all of the required information for the development team to start working on that. And the technical authority, the TA, need to also verify that there is, for example, the necessary, for example, technical information that are required for the development team to work on that requirement. For example, information might be, for example, okay, are we to use, for example, the Apple, Google ways of like integrated payment, like in-app pushes, or like are we going to redirect to some kind of, for example, leak pay provide service or payment service, and so forth. So all of those technical information need to be on that ticket before it's moved to the development team. And also, if, for example, this requirement, I'm going to call that requirement, just moving, just to make it clear. So if that requirement, for example, has technical uncertainties, for example, it's not clear how does the business want us to implement that requirement in case of technical, or, for example, it's not clear which kind of tools we need to use. For example, you are asked to implement offline saving, or, for example, booking information, but like you have not decided yet which kind of uh, offline solution you want to use. If you want to use a SQLite, Hove, or like any other type of available solution. So the TA need to first talk with the business to create a spike. So what a spike? A spike, it's basically an investigation uh, requirement or task or user story that will help the development teams to know how they need to implement that requirement. Because the problem is that what affects the effectiveness of a team to implement a requirement is most often that requirements are not properly written, or requirements are missing information. So what happens is that there is not enough information, and development team have to basically guess some of the stuff, and at the end, once the work is done, the work is shown to the PO or the stakeholder, and the result is not what was expected by the stakeholder or the PO. So that's why requirements need to be reviewed, need to be checked, need to be investigated if needed before moved to the development teams. So the technical authority, the TA, its role after development, after requirement have been set, the TA need to review them, need to add any information that might be missing, or need to, for example, decline some requirement if business is not clear enough on what they want us to implement. Okay, so let's move to the next phase. So basically, you have this graph, you have this flow. So like this is a flow of how requirement need to be reviewed. So you have the open phase, meaning, for example, business have written some requirement, or like they are currently writing that requirement. They are trying to understand what the user want, or what they want us to build. They are trying to put it in the standard, excuse me, and template that we have agreed. After that, one business is sure that they have written it the proper way. They have a ready for TDA, and also there should be a limit to every phase of one's requirement move. For for example, business should not be flooding the development teams with task or like with requirement. So like every stage of that flow that we have here need to be limited. And so like for example, business is writing the requirement. Business move it to ready for TDA. TDA, for example, can have a maximum of 5 or 6 uh, requirement or user story. And as soon as, for example, there is free space, because here also it will be limited. For example, you can do only you can only have, for example, three three requirements for TDA at a time. So after the technical authority has reviewed that requirement, if everything is all right with that requirement, everything is moved to the next phase, and so on and so on. So only after requirement has go through that phase, and we are sure certain that everything is clear and we are ready to commit, this way, after that, development can pick up that requirement. So this will help the team to be clear on what need to be implemented, so that they can properly, like they can properly or the right way solve that business problem. And so we have been talking about TA. So basically, like we said, TA is a technical authority. And if I have to recommend something, is that if, for example, you have a team that has a tech lead or a team lead, and every other developer, TA meeting, basically the meeting that take place to verify the requirement. In that meeting, you should have the technical lead, the team lead, and someone else with, for example, a senior or middle level of expertise. Why? So you need to have someone that can interim the TA, the tech lead, team lead, in case of, for example, the team lead is going on vacation and so forth. So that your team can still be effective even though the team lead or tech lead is on vacation. And I would also recommend, if you want to have an effective team, is that to have at least every week to select one person in your expertise level of your team, to select one expert to be part of the TA meeting. So every week to change that person, so that everyone on the team that is expert enough to have the knowledge needed to perform that review of the requirement, and to be familiar with that review of the requirement. So in that TA meeting, you need to basically discuss the idea or requirement presented by the business. So upstream is business. You need to analyze if those requirements are technical feasible, if they can be done, and if everything is clear on how they should be technically done. You need to also basically also go through if, for example, those requirements meet the standard, the template that you have defined. And if all of those stuff are met, you can move those requirements to the next stage. So next stage is to basically create a plan on how to implement that requirement. So basically, there is a term in software development process, which is the requirement analysis, and you have design phase. So this is similar to design phase, but like not at a large scope. So this is basically a meetings where you this meeting can be done, for example, by the tech lead and one person that is expert enough on that domain. If, for example, you have, for example, a requirement that asks you to implement, for example, a system that allow you to receive push notifications on iOS, Android, or let's say Huawei device if you have some of those. So in that implementation designing, you need to have, of course, the team lead or tech lead, but you also need to have an expert or a proficient developer in the area of push notification on native device. If you have, for example, a small team, for example, one or two, three developers, in that meetings you can have all of your developers. But if you have a large team of like five to higher, you should have in that meeting only the people that are expert or proficient enough in that domain that you are right now, that the requirement is basically close to. So if it's push notification, someone that is good enough in push notifications. If it's, for example, uh, to create some UI, someone in your team that is good enough for UI designing. If it's, for example, some kind of pagination, some kind of like API or data communication, someone which is good enough in that communication, other than, of course, the tech lead or team lead. So in that meeting, you need to basically design what should be the data that are needed to implement that requirement. You can, for example, check the API that need to be used to implement that requirement, the data structure or like the way data should look to implement that requirement, or for example, you can, for example, decide which repository can be used to implement that requirement in your architecture. You should also define, for example, which tools should be used. So if, for example, you have a requirement that need you, for example, uh, that need you, for example, to save some data, you can decide in that meeting, okay, which kind of database are we going to use first? So everyone that is into that meeting will propose their options, and you will agree on some option and put it, okay, so for this requirement we have to use this type of tool. And of course, you have to also define high level architectural component. For example, uh, if you are going to use a repository or like a service, if you need to create a data source to implement that requirement, etc., etc. And also, what is really important is to have this meeting time boxed, because what happened is that since in that meeting you might get carried away and you might want to basically get every details to the smallest bit noted to implement that things. But this is wrong because you should still allow uh, the availability of the developer to freely think about implementing that. So like you need to time box that meeting in such way that you only focus on the high level important things that are needed to implement that requirement. And of course, after you have defined, for example, those data, API, tools, and so forth, try to deconstruct that requirement in such way in such way that the requirement have a task, well, or subtask or steps that are needed to implement that requirement. For example, if you have login, one of the steps would be to define the data that are needed for login, which mean a user object, a, a login request object that has a username, password, uh, remember me, checkbox, and so forth. You need to also define also, okay, APIs, okay, so like which so like a task or a step that we should define API, a step or a task that, okay, we need to define the UI, we need to define a block, a view model, or a controller that will take information from that UI and format it in some way that it need to go to the repository or the use case. So in that phase, you deconstruct you deconstruct that requirement in such way that, okay, so you have all of the step. So once the development team gets that task, they have all of the step and they know what need to be implemented and what need to be worked on. And also on that step, you also need to go to the highest level of possible. Don't go too deep into details. So why is this important? This is important. Why? Because when you deconstruct a requirement in small bit, you will also be able to actually see, okay, so in that requirement, let's say we have, for example, UI that need to be written. Okay, so we know, okay, UI right now we have a UI expert, so we can assign that subtask or that part of that requirement to that UI expert, so that as soon as he's available, he can pick that up, work on that, and ship that. Okay, so like this help you to properly coordinate and to make it uh, faster. For example, for the development teams to know, okay, so I need to go from this to complete all of the acceptance criteria and to have these things ready. So what you will notice is that when you deconstruct a task or a requirement, you have a better picture. Give me a sec. You have a better pictures on what need to be implemented. Have this task to have this recommended completed. And what will happen is that since you have all of those step tasks defined, development go actually really fast, because you know, okay, so right now I will pick up this, okay, after this I have to pick up this, okay, this and this and this, and then even in your daily, you are able to say, okay, so right now I'm working on this, so I have this amount of work left to complete that. So you can expect this work to be done by tomorrow or today. Or for example or for example you can, for example, easily see, okay, so this requirement need, for example, for me to work on, for example, the qubit, but we don't have any documentation on how qubit need to be done, or like how we need to handle error uh, in qubit. So this also make easy visible what are the problem that need to be solved before attacking some requirement. Okay, so the part that is more important, well, for me at least, as a developer, as a team lead, tech lead, is the way that we effectively develop software. So I believe to effectively develop software, you need to have project guidelines and rules. Why? Because basically, right now, the languages that we use in Flutter is Dart. Dart allows you to do so many things in, like, to do a single things in so many ways. For example, just even iterate to some list of information. You can do a for loop, you can do a for which, you can do Recursions, you can do so many ways, so many things to achieve a single way of doing some things. So that's why in your project you need to define guidelines, rules on how to implement common things. And of course, you need to also iterate to those guidelines and rules to implement those things. For example, if for example on your code review you notice that, for example, okay, so this this type of code, I've seen it somewhere, and you see that, okay, this place it was done that way, this place is done that way, but both of them are solving the same problem. You then need to discuss as a team, okay, why was this done that way in that section, and why was this done that way in this section. And then you need to agree as a team, okay, uh, what solution or what way do we like, or that suits us the most. So like after for example deciding this, you have to update your project guidelines and rules to have this there. And then every time when someone, for example, want to do the same things, they can just go to the project guideline and see, okay, so basically, for example, like it was in the previous form. To create a form, I need to do this, or like, for example, okay, to provide access to some data, I need to create data source repository and do this. Okay, to basically convert API error, or like API exception to some domain exception, I need to do this, or to move some page to some page, or to localize some value to some value, I need to this. So this allow the teams to get familiar with how things are done project, and this also allow your teams to work faster and to work more effectively. Why? Because everyone has a common way of doing a specific thing, and everyone know, okay, so like, if if I want to do these things, I have to do it that things. And this basically switch the scope of thinking for solving a specific problem. And also, this also help you, so that, for example, when you are going through your project, if you see a part that is different than what you are expecting, that means something special is happening this part. So this help you to better understand your project. And also, even for newcomer that come to your project, they can easily start working on your project and start providing value to your project. So this, of course, keep maintains the effectiveness of the team even when you have junior newcomer coming. Okay, so the next things that help a team to be effective, or like a Flutter team, is code review. So why code review? Because basically, we have to understand that we are all different. We have Everyone have their way of thinking. Everyone have their way of going to problem solving thinking. Everyone have their way of finding solution to some specific problem. So basically, code review help you to ask a team to basically go through some implementation, some solution that someone is proposing to some problem, and basically review that solution and think, okay, so hmm, so this solution was done this way. And while looking at that solution, maybe you can have a better idea, or maybe you can basically or maybe you can basically try or maybe you can basically spot something that was missed by the person that was creating that was working on that solution. And also, some things that I found quite effective is to have, at least in every pull request, to have a junior developer also doing code review on that pull request. Why? Because basically, since the junior developer does not uh, like he's a novice in some domain, or like in some tools or solution used by some proficient expert developer working on some task, the junior or novice developer can ask really good questions. For example, if something to the novice developer is not clear, the novice developer can actually ask, and the proficient or expert, while trying to explain why it was done that way, the expert can actually also understand, okay, this was done too much this was too much complex. Maybe there is a better way of doing that. So this will make the expert think of like how it was implemented, why did it choose to implement it that way, and maybe there is a better way. And also, code review also help as a team to found patterns or like common things that are being implemented in the application. And there is one things, okay, code review has pro and cons. Because if you have, for example, a big team, let's say, for example, a team of 5 or 10 developers, not, or like 10 or more, of course, not everyone should do code review. Because what would happen is that your code review will take much more time, because you have to wait for someone to be available to do that code review. So some of the patterns I have seen, well, or like I have been applying myself in my teams to make them effective, is to apply rules to code review. One of the rules might be, okay, a code review, like a pull request, should be pending for maximum 2 days. So like if a pull request was pending from from all the 2 days, or like it's close to 2 days, everyone before starting working on their task have to review that pull request. Excuse me. And other things is that pull requests need to contain only the code or the solution that match the task that they are trying to solve, the business problem they are trying to solve. Why? Because what happens is that while you are working on some code, you might, okay, find some problem that find some place that might need some a little bit of like refactoring, and then that place also touch another place that need refactoring, and then you have and this create a large pull request, and this affect the effectiveness of a team to basically solve some problem, because like everyone has to wait, everyone has to review the 100 line of code that you have implemented to solve that problem. So that's one thing. So effective team keep the pull request short. Effective team keep the pull request for at maximum. Well, for what I have seen in practice, 2 days, it's what for my team work the best. And also, you need to automate verifications of code on pull request. So before a pull request is taken for review by the dev team, this pull request need to go some CI/CD, meaning this pull request need to be tested by some automated service. Code of that on that pull request need to be reviewed and so forth. So that's about pull request. And also, if of course you have the tools that need that, you need to also be able to track how many pull requests have been opened, how many of them have been closed, how long it has spent, like how many time has want while a pull request was opened and closed. Why? Because the goal of software, like of software development, is to basically improve the lead time of when a ID is presented and when the ID went into business. So to be able to improve on that, you need data, and you need to be able to see, okay, which part of the system need to be improved in order to have that lead time improved also. Okay, so this is about code review. Next things we have divide, conquer, and stabilize. So what is that? So what I have often see in team is that when a developer get a task and start working on the job, and if for example you have some rules or some architecture, what would happen is that the developer will try to first do his best to follow the architecture to the maximum, and then basically try to solve that problem. So what you need to do is the following. So let's say, for example, you are following clean architecture. So you have your presenter, your data layer, and domain layer. So what you can do, you can divide and conquer. So what is that? So you have to first start with doing something first. You can decide first. Okay, I want to do UI first, or like I want to do data first. I want to do domain first. So you start by working on small bit of that, and like gradually go further. So for example, you can decide, okay, I need to create the business object, the DTO first. I need to implement the API first, and then I need to implement, for example, let's say the UI or the block and so forth. So you should not, for example, like I've seen in some teams, you should not, for example, try to do all of the bit of your system at the same time. For example, right now I create uh, the uh, the object, and after the object I create the UI on that object. After the UI object, I create the qubit on that object. No, you go first. Okay, I first create the data. I create how to how to react on that data, and then I create how to present that data. So this way of doing things, it's how I have seen effective teams basically doing that, because what happens is that since you have those step-by-step stuff, what happens is that you have a concrete plan, and you can go more easier, more effectively in implementing your task. And the last thing is stabilize. So when you are writing your code, it's not it's not required for the first line of your code to be the best possible. No, you can do just like, for example, some people do in like TDA. You can do just what is needed at the right moment to make it work, and then reiterate on it, reiterate on it, and small, go to what you need for that code to be production ready. So what I'm trying to say is that when you start working on some code, you don't need that code to be at the beginning production ready. You can first have it work. After having it work, smallly iterate to that code to make it more stable and more production ready. So by stable, I mean testing, like adding testing, for example, refactoring some part of code, or like handling some part of the architecture that you have not completed. So what I found that is effective is to, while you are working on your code, to add small to dos on part of, for example, you are you are trying to implement, for example, uh, some algorithm that need to be fast and also right. So what you should do first make it work, and then add it to do, okay, this part I have to make it faster. Okay, so to do Darel Bitsy, make this part faster, or like improve this iteration for it to be faster. So first you have it working, then what you do, okay, this has to be faster. Okay, so I have to now think about how to make that for loop faster. Or like, one other thing is that, okay, so like these things might throw a exception. Okay, I had it to do, so okay, I need to handle exception here, but for right now I will write it in such way that there will never be any exception. So when you have this working, then you can go back to your to-dos and try to iterate on your code to basically stabilize that code. And well, as we have said, code idioms and pattern are basically stuff that you see in your code base that can be done in a single way, and those idioms pattern need to be added to your guideline. So architecture. So I recommend architecture to be basically clean architecture, because you have like separation of concern, and you can also basically separate your code by feature or by module in such way that everyone can work on separate part of your application. Okay, so the next things we have trunk-based development, feature branch development. For me, uh, both of them can be used by effective team. It all depends on basically if your teams is comfortable enough to basically work with feature flag, or if your team has, for example, the need to, for example, decide at some point in time in the future when they need to release a specific feature, but without impacting the production code. So trunk based in something is something in such way that say, okay, so you can be, everyone right now will be working on the same code base, but every feature will be hidden by a feature flag. And also, always, if you go to trunk based development, you have to have test, because what happens is that everyone are changing the same code, and everyone is merging into development branch or master branch. So you need to be able to be sure that if someone is working on that feature, someone is not impacting another feature. And feature branch just mean that, for example, that, okay, so like we have a production course, master branch, we have development, and everyone might be working on different feature at the same time, and at some point in time we decide that this feature is ready, this feature can go into development, no, this feature can go into release preparement, or this feature can go into basically everyone branch, or like develop. So one other practice or pattern that I have seen that is being used in effective teams, is Flutter team, is to use code generation. So in Flutter, we have many things that can be automated. For example, you can generate a asset in code to help you properly, securely access asset. You can generate, like we have all seen, from JSON to JSON. You can generate localization also to make it easy. So effective team in Flutter, they make heavily use of code generation because code generation help you to have a little bit of things, but to have many things done for you. So they help you to effectively work on that boilerplate that could in some other way slow down your effectiveness. And one thing's also like code code generation. There is many tools that you can use. There is FreeZ, JSON, serializable, and many more. And one thing's also is Git hooks. So for those who don't know Git hooks, Git hooks are small script that get executed on every Git event. So a Git event can be, for example, okay, a Git event can be, for example, when someone is about to do a commit. So what I have seen that help teams to be more effective is to perform some check before performing a commit. For example, if you are, for example, doing divide and conquer, like working on some code, you might forget to work on some to do that you have placed at some time. So Git hooks, for example, you can have a Git hook that will check your code for to do that are not implemented. And then he will let you know, okay, so you have this part of code that have not yet been implemented. Please update it before committing. So this actually help you to finish up the code in such way that it's ready for production before actually moving it for code review. And this make it so that code review always has the cleaner code that you need basically before moving it for everyone to check that code. And Git hooks also allows you to basically also check that everyone in your project is following the guideline, because a guideline are stuff that you have written, but you might at some point forget those rules. If, for example, you are, for example, an expert coder, sometimes you don't think in rules. You think in intuition. You think in in uh, in, for example, okay, so how do I do this? So like your mind does not work in rules. So Git hooks can help you still remember important stuff that you don't need to forget, even being expert. And also Git hooks also help newcomer to start working on the project as soon as possible, because like they can make mistake, but the Git hooks can catch those mistakes and help them still provide code that is good enough. So the last thing is tests. So as we have said, tests are important. Tests are really important, and you need to provide guidelines and rules on how tests should be written. Because if everyone is writing tests differently, what you would see is that not everyone can explain what the test is doing. But tests should be documentation of your code. So effective team, what they do, they also define guideline and rules on how tests should be written, so that everyone will write the test more or less the same way, and everyone will know, even newcomer will know how to write test in some project. And of course, effective automate everything. So you need to have a CI/CD on your team. You need to automate review, delivery, and so forth to, of course, effectively iterate in your requirement. Okay, so collaboration, daily meetings. So how we go quickly on that things because this is quite clear to understand. So daily meeting should not be about people. So in daily meeting, you should not, for example, ask, okay, Darrell, tell me what you have been doing yesterday. Tell me what you will do today, or what you will be doing tomorrow. No, you should go to the work that is pending and say, okay, so we have this requirement. Okay, so when can this requirement be done? What the status of this requirement? What is blocking that requirement? So daily meetings should be about the work, not the people. Next, so in a team, you have many skill people. So someone can be good in UI, someone can be good in architecture, someone can be good in something else. So you need to create a skill matrix or a document that define the technology that you use or the tool that you use and the expertise of everyone in that team on that skill. And you need, of course, to follow that document and to, of course, motivate people to improve their skills on where they are not good enough, or for example, novice or advanced beginner. Pair programming. So pair programming is really important for effective team because two mind is always good than one mind. So you can, for example, ask one of your colleagues to join you on some task and and try to find a better solution on that task. So what I've seen work better, like if you have, for example, a team that has expert, proficient, and novice, what work better is to basically have expert with proficient people per programming, novice with competent people per programming, advanced with competent or also advanced and beginner, but this is a little bit tricky. And also, so after by programming, you also have to basically document onboarding process. Your onboarding need to be defined. You need to have step on what someone need to do when he first join the project. And last things, you need to have metrics on everything you do. How long does a requirement go from definement to release it? How long does a pull request go from opened to close? How long, how many bugs are created for a specific requirement, and how much is also decreasing? So that you can know on what you need to improve your team. And of course, skill metrics, I've talked about that. And last is hack day. Effective team always have hack day. So hack day is might be one day in a week or one day in a 2 week that your team take to basically improve some code, refactor some code, or make some code better. So hack day are really important to keep your project in shape, to keep everyone basically in check. So hack day is like a team building, but everyone is working on the same stuff. So everyone is working on improving part of the application altogether, doing pair programming. Okay, so the last slide of this talk is this link. So there is this project that has that implement everything that I have said here, all of those things. So in this project, you will basically find, for example, a requirement document, how to deconstruct those requirements. You will find project guidelines, for example. You will find also architecture decisions, for example, using data source, business object, guideline, and so forth. And you will also see all of those things defined there. Okay, so that's basically all for me. And if there is any question, feel free to ask me. Thank you everyone again for having me, and have a nice day, guys. Can you hear me? Is there?
Yes, yes, I can hear you, Daryl. We have
Oh,
some
I want
questions.
a little bit. Yeah, I want a little bit overboard. So I'm sorry about that.
Yes. So we've got
Yeah,
just one question for the time. Um,
sure.
Vladimir uh, Burdeni, he says that you're the best TL he've ever seen so far. So perfect understanding of details. So he got a question. Where did you learn and graduate?
Okay, I learned in Ternopil at the technical university Ivana Poloya, but I graduated as an electronical engineer.
Uh-huh.
Programming, it was my hobby. I was learning it on my free time. I was doing some Cisco stuff, working on some basically WPF Windows application, some router. I was doing many things. So programming was just a hobby until someone basically sent me sent me a job, and then it was now my way of making money. Yeah.
Oh, like a hobby. That's great because I know lots of people who get hobby like programming and developing, and that's their job just right away.
Yeah.
So we have another one question just for you. And so far we get the question and answer session. So if you got some questions, write them to the chat. And we've got another one.
Yeah.
Can you just give us some advices how to learn more productively, more effective? How and when and where?
Okay, so basically, my advice on basically learning productively is how. So you need to first find something that you want to learn. You need to define, for example, that okay, I want to be able for okay. So let's say that okay, I have a goal. So that right now, for example, in my life, every time I want to be able to track the task that I have to do every day. And then you can be okay. So to basically doing that things, I have to learn how to do this. So you make a plan, and you have, like we said, the Dreyfus model of learning, and you basically go to first. Okay, so right now I don't know, for example, how to do data storage, and you try to start see what are the data storage solutions. So as a novice, because you know nothing in the beginning, so you can, for example, start learning only the rules. So you start first with the rules. After the rules, you know the rules, you have learned that, okay, so I have to always create object, save them, and so forth. Next, you have to try to basically understand why there is those rules.
Uh-huh.
And after
Okay.
that, you basically just follow the path until you are good enough in that technology. So my advice is to just find something that you want to create and work on creating that things. So learn every bit that are needed to create the things that you want to achieve. Yeah.
Uh-huh.
Yeah.
So love what you do. Okay, thank you, Daryl, for expertise, and we have no questions right away
Thank you.
from. So it was so clearly that you tell us that guys have no questions for you. Thank you, and it was very great to see you on this meetup,
Thank you too
and
for
willing to
having
see
me.
you next time. Uh, okay, so
Yeah.
have a nice day, Daryl. Thank you.
You too, guys. You too, guys. So this for me, it was an experiment to try to see, to try to do a not technical talk. So I hope everyone liked it. in our technical talk. Thank you guys for having me. Cheers.
Thank you. See you.
Bye.
So guys, if you love